In this video, we're going to be looking at the cofunction identities right here and try to explain at least how one of these seems to kind of connect to each other. So let's just look at this one right here. The idea that sine of pi over 2 minus theta equals cosine of theta. So to begin with, just remember this is in radian measure. If we were to put that into degree measure, we'd say pi over 2 is equivalent to 90. So this is really saying that sine of 90 minus pi equals cosine of, sine of 90 minus theta equals cosine over theta. So let me go to some blank space and try to write that down here a second so that we have that just to look at. So we say sine of 90 minus, let's say, 20 degrees equals cosine of 20 degrees. Okay. We're not super familiar with the idea of 20 degrees, but 20 is what I'm filling in for theta. And just to simplify again, we have sine of 70 equals cosine of 20. Okay? So I want you to think about that a second. On a unit circle, again, that has a radius of 1, what we're saying is at 20 degrees, okay, wherever we're at right there, that's cosine of 20. That's this part right up here. That's the x value. So whatever we get for x right there, because cosine is equivalent to x, that's going to be the same thing that I have. Say that's 70 right there. That whole angle. That x value at 20 degrees will be the same thing that I get for y at 70 degrees. Did I say that the right way? What I get for x at 20 degrees will be the same thing that I get for y at 70 degrees. And maybe from that picture you can kind of make sense of that. What I'm going to show you, I'm not going to necessarily formally prove this idea. I'm just going to show you a quick sketchpad picture of it. So I'm going to erase this. There we go. And we're going to go up to a sketchpad file right here. Let me get to about 70 degrees or 20 degrees. There we go, right around there. Okay, so hopefully, let me drag a few things over here to adjust some things again. Okay, so our angles up here, we have BC being 20 degrees. So this angle right here is 20. BD is around 70, so that's this whole angle right here. Here's what I want you to notice. Point C, the x value is 0.939. Okay, right there. And if I look at point D, if I look at the y value, it's also 0.939. So this up on top here is equivalent to cosine of 20, and down here is equivalent to sine of 70. And it kind of works the other way. Cosine of 70 equals sine of 20. And so if you just look at that relationship right there, and if I move this and stop at various parts, you're going to see that x of one of them equals y of the other. X of one of them equals y of the other. So as long as these two angles add up to 90 degrees, they have this relationship. And that's kind of explains the cofunction identities. Doesn't really prove them, but it kind of explains or shows you that they do work. So I don't want to go into it much more than that. Just a quick video to show you that this relationship does exist. We're focusing more on the cosine and sine relationship, but you certainly could go through and look at this and prove some of the tangent and cotangent relationships too. So you don't need to worry so much about explaining why this works. You just need to realize that it does and that